guys, and welcome back to Up to Speed with ElasticSearch. We are up to chapter 7, where we're going to look at different types of templates that ElasticSearch offers. So there are basically 3 types of templates that I'm going to cover in the video. The first type are component templates. We then have index templates and then search templates. So I thought I'd give you a little bit of an explanation in the slides before we move on to some tasks at the end of the video, where I'll show you how each of the template types works in action. So to start off with, let's look at component templates. I'd basically define a component template as kind of a reusable component, hence the name, that can contain settings and or mappings. So to give you a practical sort of situation where these might come in handy, if you think about every index that we've created in the video so far, we've pretty much been repeating ourselves a little bit, in the sense that we have index settings that contain configuration for 1 primary shard and 0 replicas, because we're running on a single node cluster, and we use that for every index that we've created. And we also typically set dynamic mapping to strict, and that's another thing that we repeat for literally every index that we've created so far in the course. So for situations like that, where you want to avoid repetition whenever you create indexes, or you want to take that that common configuration and put it sort of in one place, so if that ever changes, you only sort of have to maintain one source of truth, so to speak. Component templates are a nice way to do that. They allow you to define a component which contains, for example, the number of primary shards and number of replica shards, and or, for example, in our case, the dynamic mapping setting that you want to apply, and you can then reuse that component for every index that you create later. Index templates are built, you could say, on top of component templates. So the idea behind an index template is you have a particular pattern, and any index that gets created that matches that pattern will inherit the settings from the index template. And an index template can contain its own sort of settings and mappings, similar to component templates. But index templates can also be composed of 1 or more component templates. So you could have really tightly scoped component templates for very specific things, and then you can create more general purpose or more broad index templates that are composed of those much more tightly scoped component templates. And you'll see that when we get to the practical section. So component templates and index templates, really, really nice for when you're creating indexes and when you're creating indexes. We also have search templates, which are more for when you're actually performing a search. So the idea here is, imagine if you've got a really large and complicated query. Perhaps it's a query that you run by hand a lot of the time, and it's a bit annoying having to go into that query and modify different parts of it when circumstances change. Like maybe you have a particular query you run to calculate like statistics or analytics over a particular billing period or something like that. And every time you run it, you need to jump in and modify like a date range, or maybe you need to modify other certain bits of information in the query. And because it's so large, it's a bit annoying to have to modify all those different places in it. A search template would allow you to store the query in Elasticsearch, and then just invoke it later with arguments. So instead of having to search through the entire thing and make changes to the hard-coded values in it, you can just change the parameters or change the arguments that you send to the stored search template. That may not make a lot of sense just hearing it, but hopefully it makes more sense when you see it. So we have a couple of tasks, and let's get into these. So I'm just going to copy these and paste these into Kibana. Okay, so first task is we want to create 2 component templates, one that disables dynamic mapping and another that enforces 1 primary shard and 0 replicas. Pretty much the requirements or the situation that I mentioned earlier. So to start off with, we'll do a put to this endpoint component underscore template slash the ID of the template. So since we're using dynamic mapping, or since we're creating a component template that affects dynamic mapping, I'm going to call my component template dynamic mapping. You may have noticed as well that we didn't get autocomplete for this component template endpoint. I think the reason behind that is that at the time of ElasticSearch 7.10, which is what we're using, component templates were a fairly new feature, so I don't think they had the chance to add autocomplete for that particular feature. There are a couple, not only component templates, but there are a couple of other features that don't benefit from the autocomplete. Unfortunately, yeah, that's just something that we have to live with. On the bright side though, having to type it out might mean that you remember the syntax a little bit better. Anyway, so to start off with, we're going to have a template root level property, and here's where we can configure the index settings or index mappings that we want to apply. So what we want to do here is we want to specify a mappings section and set dynamic to strict. Let's go ahead and run this. Okay, looks good. If we retrieve it, we can see that coming back, so looking good. Next task, or next section, is the component template that enforces one primary shard and 0 replicas. So we're going to do something similar. We'll make a put to component underscore template, and I might call this shards, and the template is going to have a settings section. And the syntax for these, by the way, if you didn't notice, is exactly the same syntax for when you are creating an index. So you could create, an index which has settings and has mappings. So this is pretty much the exact same syntax that we're using here, and this is the same syntax that we're going to use here. So coming back to that, the setting that we want to configure is number of shards. We're going to set this to 1, and number of replicas, we're going to set this to 0. Okay, run it. Sounds good. Let's retrieve it. Awesome. Okay. That task looks good. Next task is we want to create an index template such that any indexes with the prefix of test will have the component templates applied. All right, so let's put to index templates. The ID of the template might be test, and we're going to set an index patterns of test with an asterisk. So this is the pattern where if any index matches one of these patterns, we only have one, but if any index matches one of these patterns, this template will get applied. And in our case, while we could do the same thing here, we can specify a template. In our case, we really just want to get this index template to use these two component templates that we've already defined. So this can include a composed of array, and the first template is going to be the dynamic mapping template, and the second is going to be shards. So let's run this. Oops. It's saying that we need to use post instead of put. Hold on a second. Invalid index name, index templates. Yeah, sorry about that. Nice, okay, and if I try to retrieve it, get index template test. Cool, that looks good to me. It's got a name, and it's got a pattern, and it's composed of these two. So just to test this out, let's create a new index called test-1 and see what happens. And if we retrieve it, It's got no aliases. It has dynamic mapping set to strict. It has 1 primary shard and 0 replicas. So it's inheriting all of the properties from our component templates. So that seems to be looking good. Next, task 3 is we want to create a search template that will perform a search on the Apache logs index for the provided HTTP verb, response code, browser, and date range. So to start off, I might just do a regular search to Apache logs. And we're going to have a query. The query is going to, well, we have quite a lot of things that we need to search on, so we're probably going to use a bool query here. And let's just assume that all of these things, the verb, the response code, the browser, and date range, they all must match. So this is going to be a must, a series of must clauses. The first is going to be a term. The field is going to be the verb. And let's just filter this to all post requests, for example. If we run this, we get back 5, so far so good. One more must clause is for the response code. So there should be a response. Oh, sorry. This is going to be another term query, and the field is going to be response, and the value, let's just say with 200. So that brings us down to 2, and the browser. I think we can pull this out of the agent. In fact, let's just do a quick get on Apache logs mapping just to see how that agent field is mapped. And agent is a text field, so we can use a full text search query on it. So we can use match. The field is the agent, and the text is going to be Mozilla. Cool, we're still getting back 2, and also a date range. So we can use a range query here. There should be a timestamp field that we can use here. Greater than or equal to, say, the start of 2015. So let's go with 2015 January 01, and less than or equal to, let's say, 2015 December 31. And if we run this, oops, didn't seem to like that. Oh, sorry, forgot to enter the field. That's going to be the timestamp. Nice. Okay, so we've got a few things going on here. It's still a fairly short query compared to something that you might run, but I think this is still looking like a reasonable candidate for a search template. So what we're going to do here is we're going to execute a, I believe it's a put to _scripts, and now we need to specify the name of the script. So let's call this web requests, since it's a search template for web requests. The language, is it put or post? I have a funny feeling it might be a post. Well, we'll soon find out. The language is going to be mustache, and the script oh, okay. Lang is going to be mustache, and I think we want the source, there we go, to basically be exactly this. So let's just auto indent this, and if I run this, awesome, that looks good. Of course, we don't want these like exact values here. We want to introduce some parameters to take the place of these exact values. So post, I think we can use maybe verb for. You basically use, this is pretty much mustache syntax using the double curly brackets to specify the parameters in the template. This is going to be a, let's say, response code. This is going to be perhaps the browser, and this could be, let's say, on or before, on or after, sorry. And this could be on or before. So let's run that again. Cool. And to actually execute this, we can run a get on Apache logs template, search template, and then the name of the template. So this is going to be web requests. Whoops. If we run this, does it need to be a post? Let's see. Oh, sorry. Let's get template back. The ID is going to be web underscore requests, which is the name that we gave to the template earlier. And then we can also specify some parameters. The parameters that we're going to specify are the verb. The verb here is we're going to use post. The response code is going to be 200. The browser is going to be Mozilla. And we also have on or after. Let's go with 2015 0101. And on or before, let's go with 2015 1231. And if we run this, we get back 2 results, which is the same as we had when we manually ran the script. So you can do some other more interesting things with search templates, like you can specify optional arguments and default values for arguments and things like that. But I think I'm gonna end the video here, and I will see you next week, where we look at index lifecycle management and data streams. Thanks very much for watching, and I will see you in the next video.